All right, let's first, central angle. Central angle of a circle. An angle whose vertex is the center of the circle. Take a look at my diagram right up here. Can anybody identify a central angle? An angle in this circle where the vertex is at the center. What's an example of a central angle up here on my diagram here? Name the angle. Mike? Angle AOB is a central angle. Yep. Why? Because the center of the circle is the vertex. All right. Anytime the center of the circle is the vertex, we refer to it as a central angle. All right. Arc. A part of the circle defined by two endpoints. So I'll give you one right now, and that is arc AB. There's a symbol for arc. It looks like a little umbrella. Arc AB. And when we name the arc and I give you these two letters A, B, I'm going right from A to B, no stops in between. Because some of you could argue with me now, well, couldn't that also be AB? Not in here, we're not. Because if I wanted this arc, guess how I would name it? Three letters, ACB. So know the difference between arc AB versus arc ACB. All right, here is arc ACB. Here is arc AB. You go directly from the first letter to the second one. No stops in between. Here's your first fact of the circle unit, and this is the how do I find the measure of a central angle? The measure of any central angle. Woo! So this angle right here, how do you find how many degrees are in it? Everyone ready? It's equal to the measure of its, and I'm going to use a new term here, intercepted arc. Ooh, hoo, hoo. Mike, what was the central angle you gave me a couple minutes ago? AOB. Using this theorem, angle AOB is going to be the same measure as the arc that it forms. AOB forms what arc? Arc AB. So whatever arc AB is, the measure of arc AB, that's going to be the same as angle AOB. They will be the same degree measures. So if this is 60, so is the arc. If the arc's 75, so is the central angle. All right. Questions? All right, so again, the central angle is equal to the measure of its arc. We'll practice that in a second. Before we get to that, though, different kinds of arcs. Semicircle, you've heard that one, I think, before in the past. Half a circle. Okay, half a circle. While we're going through here, name a semicircle in this first circle here. Name the arc that represents a semicircle, and you could go two different places here. Name an arc that represents a semicircle. Let's do it. Nobody. Great. Yep. Just. Anybody want to take this one so we can start the chain? Justin, roll. TS. Good. And how do I know Justin? Hey, everybody. I know Justin's referring to this arc right here because I'm going right from T to S, no stops in between. What else could he have had instead? I could have said TRS. This is also a semicircle. Good job. Justin, going to need a number here in a second. Major arc. Major arc is one that's greater than a semicircle. An arc that's bigger than half the circle. Need a number 1 through 20. 6. RTS. I like it. So I'm going to go from R to T to S. Everyone see? RTS. Bigger than a semicircle. And then a minor arc, smaller than a semicircle. Smaller than a semicircle. You got a number 1 through 20, Nick? 8. RS. Yep. Was that your own? Would that have been your only option, or is there another one I could have picked?
No.
RS or RT. Okay. Everybody good with semi versus major versus minor before I let you do a little group assignment? Okay. Second one in your group, find a minor arc for me. In your group on the third figure, find a major arc. Okay. So in the second diagram, please find me a minor arc. And in the third one, find me a major arc. Need a number, Nick?
20.
20. Minor arc? RS. There's one example. Yep. Could have had TR as well. Number? Major arc? RTS. Oh, before you go on to the next page, I didn't mention this. Semicircle. You know how many degrees in a semicircle? Anybody know the measure of TS here? Or TS here? 180 degrees. Okay, so just make sure we're aware of that. 180 degrees. All right, nice job, everybody. Adjacent arcs. Exactly how it sounds. What's adjacent usually mean in the old mathematics world? Next to. Two arcs that are next to each other. They share a common point. They share a common point. Amy, need a number here. Somebody can find me adjacent arcs. 12. Can you name two adjacent arcs up here? Two arcs that share the same point. Okay, so AC and BC. I like it. Here are the two arcs that Emma just described. There's AC, and in yellow, there's BC. Two arcs that share a point. Okay. All right, now you're actually going to find the measures of the arcs. So in this first one, circle C. Review from yesterday. C. If I call it circle C, what's the importance of C? It's a center point. It's the center of the circle. And that's helpful because I know ECB is a what? If C is the center, ECB's got to be a? Who hasn't been out? What can I call segment ECB? Diameter. Everybody good? Diameter. Everyone's all right. I'm not asking. I wasn't asking for anything tricky there. All right. So here you go. What's the measure of arc AE? How many degrees are in arc AE? No idea. But if we go back to your theorem, what did our theorem say? The arc is always equal to the central angle. Okay, so if we go back to this example, maybe, there we go. AE is going to be the exact same measure as angle ACE. Does everyone see how I'm using this fact now? That any arc is always equal to the measure of its central angle. And I don't need to see this the whole time, every time. I just want to show you where I'm going to get my degree measure from now. Now, what's the measure of angle ACE? I think you guys can find that on your own. Emma, give me a number. 10? 10?
Oh, 10. Sorry, wait, what?
Okay. I'm trying to find the measure of arc AE, which is the same as its central angle, which is 90 degrees. Got it. Are we okay there? How I got 90? I know some of you are going ahead, which means you're picking it up. Luke, need a number.
9.
Okay, 9. How about ED now? ED, the measure of this arc. 50 degrees because this is supplementary. That's 50, which means that one has to be 50. Nice job. Follow the letters because now I put 3 in now. D to B to A. D, B, A. 2. 220. Nice job, Will. Everyone all right? Will, let's go. Need somebody for 4. A, E, D. A to E to D. Follow the letters. $1.40. A, B, D. Need somebody. 220. It's the same as DBA, right? Same arc. And finish it off, Sean, with somebody for BD. $130. It's the same as the central angle. Guys, are we okay on this fact? Because this is the half of what I need you to pick up today. Everyone all right that the central angle is always equal to its arc measure? All right. Everyone remember your good old pie charts back in the day? Okay, here you go. I didn't give you the angle measure, though, so that's going to be a problem. But I still want to find arc BC right now. How many degrees do I have right here for track and field? 18%, when I did not give you the central angle. Can you find the central angle, though? How? A little help? If I know the central angle, I'll know the arc measure. Sean?
Well, I did 360 times 2.18.
You know all the degree. If I added up all the degrees, they'd add up to what? 360 degrees in a circle. And that part, this arc takes up what percent, Sean? 18%. So do I want to do this? Go ahead and do that. You're going to get a number a little larger than 360, which might be mathematically impossible. 0.18, yep. Yes. From all 3 vertices. Yes. And it's the center of a circle you can draw on the outside. Yep. 64.8 degrees. And I have no idea. I got to get rid of this. Every year I forget to delete this one. CD. It's 18% again, 64.8. I am going to add in a part C, though, for you, because you got enough room to do a part C. Everyone ready? Find the measure of arc AFD now. AFD. Remember, go right, follow the letters A to F to D, and you'll see the arc I'm looking for. I know I left out E. I don't need it in there, though. A to F to D. Who's the last person to get max? Need somebody, 1 through 20. 18? 158.4 degrees. Okay, everyone just stop for a second. Just stop. Because I'm going on to something new here for the second half of the notes. Anything you guys want to ask? Are we okay on what a central angle is? Center's where? Never mind. Vertex is at the center. It's always equal to its arc. Any questions about that? Okay, now, a little bit different of a concept. And that is how to find arc length. All right. Here's what we've been doing. We've been finding the measure of an arc. Out of 360 degrees, how many degrees is an arc? Now what I'm going to do is how long is it? That's what we're about to do now. So I want you to notice the difference before I show you how to do this. Go ahead, Cameron.
Okay, so like, say AOB was equal to like 18.
18 degrees.
Yeah.
That means this is 18 degrees out of 360. Now I actually want to know, I cut out this arc, stretch it out, how long is it now? That's what I'm about to show you. We okay? Go ahead, just keep asking, because I want to make sure you guys know the difference between what we just did and what I'm about to show you. Correct, which is not in degrees. It'll be in inches, centimeters, meters. Okay? We all good? So here, earlier in class, I was showing you how to find it in degrees. Now we're actually going to stretch it out. We're going to measure the length of it now. Okay? Which is a formula not given to you, unfortunately. Here it is. It's not too bad. If you want to find arc length, it is equal to the measure of the arc, which you guys know how to find. That's what we just spent 20 minutes doing. The measure of the arc will be equal to its central angle. That's that number that goes here in degrees. Good? Out of 360 times a formula you're pretty familiar with from yesterday. What's that formula from? Circumference formula. Okay. All right, we're ready. So the measure of the arc in degrees over 360 times circumference. All right, and again, you don't need to do this, but it's just times the circumference. All right, find arc AB. Leave your answer in terms of pi. What's that? Oh, terms of pi from yesterday, meaning what should I have in my answer? Pi. Don't hit the pi button on your calculator. All right, let's see if somebody can help me out. Who was last ups? Hugh? 5? All right, here we go. So I want to find the length, not the measure. The answer's not 90 here. 90 is the measure of the arc. I'm looking for how long it is, and I already gave away part, Mike, but what is the measure of this arc? It is 90. Everyone all right? Why? Because the central angle is 90 over 360 times pi. What's the diameter here? 24. And you guys just started yelling at, leave pi in your answer. Leave pi in your answer. Okay, I will. So what are we doing? 90 over 360 times 24. And leaving the pi in the answer. Need somebody, Mike. 13. Not here. See ya. 12. 6 pi. Chairs, oranges, corn shackles, inches. Everybody good? Next one, CDE. Again, guys, follow the letters. How long is arc CDE? This one right here. How long is it? All right, Emma, let's go. Number 14. Be careful. What is the measure of CDE in degrees? But I don't want to put 40 here because that's not the measure of the arc I'm looking for. This is 40 degrees right here from C to E. You tell me. How many degrees in a circle? You already know that part's 40, right? So that other part has to be? Oh boy. CDE. Or this way. I don't, whatever you want to. I just want to know how many degrees are in this arc. 320. Hey, everyone all right? 320? Over 360 times pi. What's the diameter here, Heaven? 18. Yep. Got to have pi in the answer. 16 pi? 16 pi centimeters, thank you. For number 3, do you know which one we're looking for? FH. Right from F to H, no stops in between. If I wanted the other one, I'd call it FGH. So right here, F to H. Whew, all right, getting tricky now. Evan, number. 4. Can I get the measure of FH? 135, that's this one right here, right? 90 and 45 add to 135, right? So that would be FGH. So 225 out of 360 times diameter in this one, 6 meters. And I think this comes out to be a short decimal, so no big deal. 3.75 pi meters. Are we all right? Yes, Justin.
Can we keep it in fractions?
You can, yes, you can. Perfectly acceptable. Other questions before we just get to this doozy? This ties in yesterday and today. Let's get after it now. Find the circumference. Everybody stop. Formula. Formula? Pi d or 2 pi r. Regardless, you're going to need to know something about the radius or the diameter to finish this problem. What else do I give you? The length of JK. Seriously? 6.09. That's the length. The length. That's how long it is. Not the measure, the length of it. Round the circumference to the nearest tenth. What are we going to need again for circumference that we don't have? Diameter or radius, right? But what did I give you? The length of the arc. How was this 6.09 produced? If it's the length of the arc, how was it produced? The measure, which we know is already is what? I gave that to you. 50 over 360 times what? Pi d, which is another name for what? The darn circumference. So does everyone see right here? There's the circumference right there. Everyone sees? There's the circumference. So I need you guys to get the 50 and the 360. Get it out of there. Get the 50 and the 360 out of there somehow. Get that pi d by itself. What do you want to do first? Or we could do one step. Simplify it. You can. Now I'm still in the same predicament as what the heck do I do with that then? Well, why do I want to subtract it? It's being multiplied here, right? It's not being added. Help, Justin?
You multiply it by 360 and then divide it by 50.
Okay, so you want to multiply both sides by 360 first. Multiply both sides by 360. And we end up with 2192.4 equals 50 pi d. And then divide both sides by 50. Yep. Did anybody just multiply by the reciprocal here, 360 over 50? You could do that too. Pi d comes out to be a nice long decimal, right? Do you guys, what's pi d another name for? Okay, so do you see you don't need to divide by pi after that? If some of you guys are trying to get to the diameter, this is circumference right here. And I can round that to what? 43.8 43.8 inches. Yep. If you want to divide by pi and then plug it back in the formula, you can. It'll get 43.8 still, but all right. Okay, let's go. Helps if I stop the video.